Hi class, welcome to GradStats Lab 1. We are going to get started with some foundational work in working with SPSS and R. So I'm in the modules area and I'm going to foundations. And then on this I'm moving over to the foundations tab. In this area is where you're going to find any materials needed for our lab today. So in our first part of the lab, we're going to compute scales and write a sample description. And some of the materials you're going to need are the lab sheet, the R script, so the beginning script for working with R, the data set, and this article by Donnellan et al. Regarding the personality scale for Big Five. So download each of these and put them where you can find them in your My R stuff or wherever you're putting your working directory for working with SPSS. So we will start with SPSS first for this lab, and then we'll do the second part, redoing the same tasks in R. That way you can compare your results across these two platforms and see where that they are the same, hopefully. So we'll get started with your lab sheet. It starts with just an overview of what we're doing with the lab and what our tasks are for Lab 1. What we're going to do is read in data and ensure that the variables are recognized correctly. Then we're going to compute scale level variables, and this is all part of getting the data ready for analyses. And then the last thing we'll do is look at some specific descriptive analysis for describing the sample, so the people, the cases in the data set. Keep in mind you want to often do saves. I find that if something's messed up, I can usually go back to just a prior version of my save and be able to continue instead of having to start from the very beginning. And I would suggest using a naming format that helps you later. Like if you know that this is part of your Lab 1A and that you're going to need to turn in output later, you would want to go ahead and name it in a way that you can find that file quickly when you're uploading materials for submission. And then the lab files that are going to be submitted, they'll be submitted during the homework 1 assignment. So you're not submitting anything during the lab, but you're keeping those files handy so that when you do your homework 1, you have the files accessible. A couple of things you need to have to get started. I want you to review the article. Just go ahead and skim through it. I'll go to it here so you can see. It's 14 pages, just getting an idea of what they're doing. And what we're going to be working with mostly are the information at the end. So the table of the items and also how to score the items down here at the bottom. So you want to be familiar with getting to those areas in the document. And you need to download the CSV, which is that data set that is in your Canvas area. I'll also link materials to the description in the YouTube, so you should have access to the materials one way or another. All right, let's get started. Our first task is reading in the data, and it can be the easiest or the most frustrating thing you've ever done. When it goes simple, it's like, oh, no problem. When it sticks or has like glitches and you can't figure out why this data is not loading in, it can be the most frustrating thing in the world. So just pay attention to details, and I'll typically show you a different way of loading in data for each lab so that you start building up all kinds of ways to make sure the data are coming into the analysis software correctly. So we're going to open SPSS and navigate to select the file Import data, CSV data, and then navigating to where that data is located. And it's called the Lab 1A Descriptives CSV. That's the one you want. That's what downloaded from Canvas or in the description area on the YouTube. When you open it, you're going to get a dialog box. And mainly the only thing you have to check out here is that it is a comma delimited file, because that's what we're telling SPSS it is. That's what a CSV is, comma separated values. So as long as that's fine, you should be good to just hit OK. And this will read in your data to SPSS. So now we have an output window and our data editor window. So we need to look through the variables, because just because it read in doesn't mean it did everything correctly. Looking over our variables here, we have case ID, which we know is a nominal type of, it's just a name, it's just a unique identifier. We can even say this is the case ID. It should be nominal, so I need to change that. Year, ethnicity, and gender, all of those are nominal. Well, year is ordinal. Year is ordinal, ethnicity and gender are nominal. So let's make those changes. And then year of birth is scale, and then all of these others are scale. So if you set one to scale, you can usually copy and then just paste it to the others. Sometimes that'll work. What if I use the shortcut menu instead of keystrokes? Okay, it liked that better. Usually I try a couple of different things until it behaves. When I use the keystroke of command copy and command paste, it didn't take it, but when I used the right click shortcut menu, there it took it. So just take one thing at a time and make sure everything's cleaned up. So now I have case ID as a nominal. I have year as far as it's the college year as ordinal, and then ethnicity and gender are nominal. Everything else is scale. Make these initial changes to your measurement type, and then this is a good time to save the data set. So now when I save it, it's going to save as an SAV, which is what we want. Alrighty, so we have case ID, we have these. We're going to update the labels and the values. You see that I already started updating the labels. This is to give us an idea as to what those variables are, and it makes it way easier to work with as we go along. So for the IP items, we get that information in the table of the appendix in the document itself. So first we're going to go get that information. And here's all of the items. I can try copy pasting this into there, or I can just type it in. Either way, I'm going to try copy pasting just to see what that'll do. So I'm going to get a new Word document. And paste the items. I don't really need all these numbers. Okay, now I have all of the actual items into the data set as well, in the labels. And that way I can just look at it and see which one it is. What else do we need to do? We need to change the values because they should correspond with 1 through 5 in this way. So I'm going to go to values here. I'm going to move my sheet so that I can see it even when I'm working with the data set. Kind of like that. The way we set values is to get the dialog box under value labels for that item, and we set each one. One should be strongly disagree, and then click add. Now I'm ready for 2. Somewhat disagree. Oops. Once they're all in, I can hit OK, and I would need to do that for all of these, but there's also a way to do it in syntax, which I'll show you a little bit later. In the lab. As for year of birth, we can just call it year of birth. The remaining nominal and ordinal variables can just be saying what they are. That the college year, I need to set what they are. See what I mean? So 1 is freshman, 2 is sophomore, 3 is junior, and 4 is senior. So those need to be set up. And I need to set up ethnicity, right? So ethnicity, we have 1, what else is going on here? Gender. We need to get gender. Okay, I think that is it for our labels and values. Like I said, we'll go ahead and put the rest of these values in. You can do them one at a time, or you'll see in syntax later that there's a way to put in all the labels all at once, the values. And this is a good spot to do another resave on your data set. Like I said, it's good to continually save, or even save with a version up if you're concerned, so that you can go back to a prior version if you need to. Task 2 is to compute scale level variables, and we're going to compute an age variable and also scale level variables for the big 5 subfacets. So what's going on is, what was asked on the survey was what was the birth date, the birth year, not someone's age. So we want to have an age variable that tells us how old the participant was at the time they took the survey, at the time of data collection. Data collection was in 2018, so that's what we're going to do, is compute an age variable from the year of birth. To do this, we'll go to transform, compute variable, and then in the target variable area, that's going to be the name of the new variable, we'll call it age. In the type and label, it's already a numeric, so that's good. The label is going to be the age of respondent in 2018. We'll continue there. And then we got to build the expression up here in the numeric expression box. So we're going to say we want 2018 minus the year of birth. I'm going to double click that and it'll place it in the numeric expression field. So we're ready there. Instead of OK, I want you to hit paste. So the first time you hit the paste, it's going to open up this syntax file for you. And this is where you can build your syntax and start getting comfortable with how SPSS syntax reads. How is this telling SPSS what we want? So this first one is just when the data set was activated. Activate data set 1. And that's what the data set is, data set 1 right here. We can put in comments by leading with an asterisk. You have to end your comments with a period to tell SPSS that that's the end of your comment line. And then it's ready to run. Like, you can tell that this is ready to run because it's all in blue. If you had something not ready yet, it would be in red. So I'm going to select all of this and hit the green arrow to run it. Here at the bottom is where you see what it just did. This is my output window, right? Compute age variable, that's my comment. Since I selected it, it's also in my output. And what was done and what the label would be. And if we go to our data editor window to variable view, we can see our new baby variable right there. So we got our baby variable. I want you to move the age variable up in the variable list up to just after year of birth. So to do that, you just take that row and you drag it up, and you see that red line moving up with it to right there. So reordering our variables in the order that makes sense for us. This is another good time to save the data set. All right. So that's an easy one, creating one new variable based on another. For creating our scales, so the big 5 scales, we need to do a couple more jumps. One, we have some items in that scale that need to be reverse coded. And if you go over to the Donnellon, you'll see that they tell us which items need to be reverse scored before we create the subfacets. So we have 6 through 10 and 15 through 20 that need to be reverse scored. Reverse scored just means turning them around because they're actually worded oppositely. So you always want your scales where higher scores mean more of that thing. So if I had a measurement of extroversion, I want higher scores to be more extroversion. And if I have reverse coded items in the scale, in the survey, I need to swap them around before I combine them to their subfacets. So the first thing we got to do is reverse score those items. To do this, we're going to transform and recode into different variables. Bring this over here so we can keep an eye on it. We want the variables that we're recoding to be placed in this input variable area. So we know we want 6 through 10, and we want 15 through 20, right, according to Denellen. Now we're going to take each one and rename it, give a new name to the new variable that we're creating here. And what I would say is do the same name, IPAP6, but then put an R after it. And the label should be reverse coded. When I hit change, it's going to add that new name, the numeric variable and the output variable, how the new name is going to be for that new output variable. And we need to do this for each one of them. So we're going to speed this up a little. Okay, once we have all the new names put in there, we're ready to go to old and new values. Here is where we're letting SPSS know what the old value is now going to be to the new value. So the current 1 will now be a 5, and you add that in. The current 2 will now be a 4. 3 is going to stay 3. 4 is going to become a 2. And 5 is going to become a 1. A good way to check it over is just to read down and up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We're good. So I'm going to hit continue here. And now I'm going to paste so that it goes to my syntax, right? Actually went to the wrong syntax. So this is what it came up with. Notice that we could have just written this in. We could have written out all of these variables that need to change. They're only separated by a space. And then the information on what they're changing, as far as 1 makes 5, 2 makes 4, 3 makes 3, 4 makes 2, and 5 makes 1. Into is what we're using to say that this is going to be a new variable. So I'm not changing IPIP6. I'm changing IPIP6 information into a new variable called IPIP6R. So then, same for all of these. And here are all the reverse coded new variable labels. So I could have also just written all of this in syntax instead of using the dialog box. Once you have syntax that you can use, you can save the syntax so that you can use it in the future if it's a scale that you're using often and calling it always the same variable names. So now we can take this bit of syntax and run it. and it ran it down there. We can double check in our data editor that we have all of these reverse coded items available now. From there, we also want to reclass those values. Like now it's opposite, right? Now, starting here, 1 would be strongly agree. 2 would be somewhat agree. 3, neither agree nor disagree. 4 is somewhat disagree. And 5 is strongly disagree. Now, I said I'll show you how to do this in syntax. Let me grab that. And show you in the syntax here. This is saying the value labels for IPIP6R to IPIP20R, because all the R variables are together, right? If I go over here into the data set, 6R through 20R are beside each other. There's nothing in between them. Because it's that way, I can say, hey, go from point A to point B. If you have variables between there, like any in the middle, it won't work out very well. You'd have to name them individually. But because they're all sequential in the data file, I can do it like this. I can tell SPSS, take all of those. And then I want this new setup on the value labels, and we can execute that. So it does it, and if we come over here, now all of them have the new value labels without having them type them in each one at a time, right? You can do that same thing to the ones before, because they're all in a row, right? And they go the normal way from disagree to agree. So you can write in the syntax right here, use that same method to make labels for the 1 through 20, the non-reverse coded items. And those would be going from disagree to agree. Or if you want to do them one at a time, that's fine too. Okay, let's see what's next. Oh, if you want to see where I got that syntax from to make the variable labels and value labels just using syntax, that's the website for it. So now we have the reverse coded items, and we're ready to actually combine the ones that are needed for each of those big five personality attributes. So we'll make one at a time, and we'll call them OPN, CON, EXT, AGR, and NEU for those. So let's do the first one. Well, let's do extroversion since I have it here for you. If we look in the paper, in the Donnellon paper, we see that extroversion is the mean of items 1, 6R, 11, and 16R. So to do that, we'll go to Transform, Compute Variable. We're going to give it, here I'm going to do Reset here so that it resets everything and I don't have to worry about it. So my target variable will be EXT. And in type and label, you want to use your name for it. So this is going to be extroversion. It's going to be numeric. We're good there. And the way that this is going to be computed is by mean. So I need to go into this function group down to statistical, And then once I hit statistical, it opens some options down here. So I want mean. And when I double click mean, it'll go up into my numeric expression box. And it says mean of what? So for extroversion, I want 1, and it jumps right there. For 6, I need 6R, so I need to scroll down to 6R. You see how it left that question mark there? I want to take that out, and the only thing separating these is a comma. So I'll put a comma before going on to 11, double click to jump it up there, comma, and now I want 16R. There's my 4 that are making up extroversion. And again, I'm going to hit paste, and it's just putting it on the wrong syntax file because I have 2 open, but that's what it looks like. So here, let's look at what this says. Compute a new variable called ext, and that is going to equal the mean of these items in the parentheses with commas between them. It ends in a period. The variable label for ext is extroversion, and notice it has a single quote, an apostrophe before and after, ends in a period, and then execute. When I select this and run it, I now have the new baby variable there, right? So we're going to do that with the rest of them, but notice that I can just use this. I can copy and paste and then change it to what I need. For example, for OPN, for openness, that would be OPN, and I need the items for openness right there, separated by commas, and then it's going to be openness. And now I need to know what are those items. So on to Nullen, it says openness is 5, 10R, 15R, and 20R. So IP 5. Oops. I don't think the space matters, but just in case. 15, well, 10R, I'll go ahead and, it doesn't matter what order either because it's just taking the mean of 4 numbers. IP 15R and IP 20R. I'm not sure that the case matters either, but I'm going to run it and see what it does. Oh, it ran just fine. It didn't say, hey, I don't have one of these. When we get to R is case sensitive, whereas SPSS is not so much. So now you can use that type of coding to just go ahead and write the others, or you can use the dialog box to make the others as well. You can use the transform, compute variable, and create each one individually as well. I'm going to grab the syntax that I already wrote, and then I just have them all there. And like I said, if I'm using this scale more than once and I save the syntax, then I'm able to just run it whenever I need it. So now I have all of the 5 variables. I'm going to go ahead and put them in order of ocean order just because that's what I'm used to. Here we go. Let's see what's next. Okay, we are ready. We have all the variables calculated. All of our study variables would be the big five facets and then the demographics, like what college year they are, the participants, the ethnicity, gender, and age. So now that I have that, I'm ready to describe my sample in terms of their collective summary scores or summary statistics in each of these areas. And when we're describing a sample, it depends on if the variable is categorical or continuous. For categorical variables, we use frequency, and we're trying to note there how many is in each group and what percent of the whole is being represented in the sample. So to do this, we're going to go to Analyze Descriptive Statistics Frequencies. I'll go ahead and save my data set real quick too, because we just made all those variables. Analyze Descriptive Statistics Frequencies. And the ones that are categorical are going to be year, ethnicity, and gender. And then I'm ready to paste. And this says I'm asking for frequencies of the variables year, ethnicity, and gender in the order of the file, in the file order. So running this. Okay, we have that there are 28 and 0 missing on these three variables. So they all answered the college year, ethnicity, and gender questions. For college year, there are no freshmen. We have 10 sophomore, which represent 35.7% of the whole. 12 juniors, and 6 seniors. The 2, 3, and 4 is just what that label number was. 2 was a sophomore, 3 was a junior, 4 was a senior. For ethnicity, we have 15 Caucasian, which is 53.6% of the sample. 7 African American, which is 25.0% of the sample. 1 Native American, which is 3.6% of the sample. And 5 that are multi-ethnic, which is 17.9. And then our male-female distribution as well. When it comes to describing continuous variables, now we want mean and standard deviation. So to get these, it's similar. We're going to analyze descriptive statistics descriptives, and we want the variables for age and the 5 personality traits that we just made, those variables. Analyze descriptive statistics descriptives. So age, and then the big 5. I'm going to paste, which puts this bit of code into your syntax. Asking for descriptives on these variables, which will give me the mean, the standard deviation, and the min and max. And that gives it in one table. We see that there are no missing. All 28 cases answered all the questions there. A min and max on the age from 19 to 45, the average age of 22.3, with a standard deviation of 5.8. So this is the information we would need for writing up about the sample, all of this. So what does a write-up look like? Well, kind of like this. It can go in different ways, but you're basically letting your reader know the holistic characteristics of the participants in your sample. It was 28.6, almost 30% male, so that means around 70. Like, you see the distribution of gender across those two. We have sophomore, junior, and senior represented. We have age and ethnicity. And we let the reader know that participants completed the Big Five personality traits and how those came out. Because they're continuous, we're reporting mean and standard deviation. So that's what you have for SPSS. The files you want to keep from this lab that you won't turn in until you do homework 1 are the output, the syntax, and the data set. And they have different extensions. So when you save the output, well, this one's the syntax. When you save the syntax, it's going to be an SPS extension. And like I said, it'd be a good idea to name it a way where you know what you're looking for. Lab 1A syntax. And when I save that, to desktop, there it is right there, SPS. That's the extension for syntax files. And you notice I can see all of what I just coded without even having to open up the file, right? Even if I didn't have SPSS on my computer, I'd still be able to see what the syntax write-up was. And then saving the data set is already saved. I need to save the output. And the output's going to save as an SPV file. Lab 1A output. That's just what it is. I don't even have to tell the computer what to save it as because it knows it's got to be that type of file. So there's the output, and you notice I can't just see the output, but that's an SPV file. Okay, that's it for the SPSS portion. Hi. Okay, for our second part of Lab 1, we're going to go a little bit deeper on looking at the variables and describing them in our data set. And we're going to do that by first doing a little bit of assumption checking, namely checking the normality, the normal distribution of the continuous variables in the data set. So to evaluate normality of continuous variables, we start by visually inspecting them, getting graphs and looking at them. We also use tests and summary statistics of normality and skewness and kurtosis to also inform our evaluation of the normal distribution of a variable. And we look for if there are any outliers in the variables. And all of this helps in writing up that summary of your data set to let the reader know which variables might be violating a normal distribution. So what you're going to need, you'll need this lab sheet of directions, and you'll also need the data set from Lab 1A. The first thing we want to do is visually inspect histograms. So I have the Lab 1A data set open, and we're going to go to Graphs and Chart Builder and select histogram from the gallery list to get that histogram going for the age variable. Here in Chart Builder, I'm going to histogram and then simple histogram, just dragging it up into my chart preview area and grabbing age and putting that on the x-axis. Here I'm going to hit paste, and that's going to open up my syntax window to work with. grabbing all of this. And it just takes a little while to run the graph. There we go. So now we want to take a look. One of the assumptions of parametric tests is that the variables are normally distributed. And you want to just look at it. Does this look normally distributed? Not really. You have a nice, heavy, strong, positive skew there. But first thing you do is look at your variables. I'm going to double click here to open up the chart editor, and I'll use this toggle to add the distribution curve to this graph. And the one I want is normal distribution. So after that's selected, I can close, and I can close this, and it adds it to the graph in my output. We also look at tests for normality and measures of skewness and kurtosis, but because the tests are influenced by sample size, it's always a good idea to first look at, visually inspect your variables. Histogram's a really good way to just start with that. So we're going to use explore function to evaluate Shapiro-Wilks test, skewness, and kurtosis. So we'll go to Analyze, Descriptive Statistics, and Explore. In here, we'll have age as our dependent variable, or as our variable that we're looking at. In plots, you want to turn off stem and leaf, but turn on histogram, and also check the box for normality plots with tests. And that's what's going to give us the Shapiro-Wilks test. Continuing here, and that's all we need. You're going to paste and run from syntax. And here it's telling us that it's going to run the function examine, that's what explore is, with the variable age. It's going to give a box plot, histogram, and the normal probability plots, and these other items. So let's run this. And here we go. We have the descriptives, which has all of those summary statistics, including the mean, the standard deviation, the median, and min and max, and also skewness and kurtosis. Now your typical cutoffs for skewness and kurtosis, skewness would be plus or minus 1. As long as you're within, closer to 0 is less skewed, more of a normal distribution. But once you get past either -1 or +1, you have a very skewed distribution. So we can see, according to the skewness estimate here, that it's greater than 1. Kurtosis, anything above a 3 is spiky, like peaked, and so it's got very thin tails. It's just really sharp, tall. And if you have it under 3, if you have a kurtosis value under 3, then it's kind of flat. It's got long tails, but not many spikes. So your cutoffs for kurtosis are around 3. You're looking at over 3 and under 3 for kurtosis. And then here in the Shapiro-Wilks test, you have the test of normality. The statistic itself is 0.559, and it's significant. And whenever you're doing tests for assumptions, if you have a significant test, it means the assumption was violated. So we're looking at the test of normality, and it was a significant test. Therefore, this distribution is not normal. So the one thing with significance when you're looking at violations of assumption type tests. Okay, let's see what's next on here. It's just annotated output here for you to check out. And our next task is evaluating outliers. So we're going to go back to the Analyze Descriptive Statistics dialog. Analyze Descriptive Explorer. And put age. Keep age in the dependent field. Add case ID variable to label cases by. In the statistics area, include outliers. In the plots, you still should have histogram on, stem and leaf off, and normality plots with tests on. And then I think that's it. Yes, let's paste and go look at this syntax. So now we've run the age variable through Explorer 2 times. This first time we were just looking to get the information about skewness and kurtosis. But the second time we added some information so that we can also get details about potential outliers. So looking at these two, the differences are, we have one line here where we told SPSS to label cases using the case ID variable, and there's a difference right here. So on the first one, before we asked for outliers, it was only telling us descriptives, but now it's got another call here called extreme. So let's run this one and see the extra information now. It's the same descriptives table we had before, but now we have this table of extreme values. And looking at this, in the age variable, it's saying that the highest values in that variable were right here. 45, 38, 26, 24, 24, 9, and then that's it. Then it goes into the lowest ones. Notice that all the lowest ones are 19. But here in the highest values, you have a 45, a 38, then 26, 24, 24. So those right up there are kind of not only high, but they're separated from the rest of the data. The trend of the data is really clumped together, and these are standing out there really far away. And there's their case ID numbers, number 1 and number 19. And again, the same Shapiro-Wilk test. So if we scroll down to the bar graph here, they have them labeled as 1 and 19, the 45 and the 38. So that's a good graphic to have if you're trying to communicate about your non-normal data. Let's see. So we looked at just checking out a continuous variable. We looked at age, but we can look at all of them. Remember, in this data set, our final variables of interest were openness, conscientiousness, extroversion, agreeableness, and neuroticism. And I'm going to move those up to the top. So here's all of my study variables. But out of them, the only ones that are continuous are age through neuroticism. I have year of birth, but it was just a date so that I could calculate age. So those would be my study variables, all of the continuous ones anyway. And looking at their normal distribution is one way to describe your data in your sample to the reader. And what would this look like write-up wise? I put a little example write-up here that if I found non-normally distributed variables that were my study variables, then I'm going to want to let the reader know about that. So here's a little example write-up of what that might look like. Okay, that's it for the end of Lab 1 for the SPSS portion.